GDB, how to understand core dumps. Imagine your program crashes unexpectedly, leaving behind a snapshot of what it was doing. That snapshot is called a core dump. It's like a photograph of the program's memory at the moment of failure. Understanding this photo can help you find out what went wrong. GDB, which stands for New Debugger, is a tool that helps you analyze core dumps. When your program crashes, GDB can load the core dump file, along with the executable file that created it. This allows you to see exactly what the program was doing when it stopped working. First, you need to make sure your program is compiled with debugging symbols. This is done by adding the flag during compilation. These symbols include variable names and line numbers, making the core dump much easier to interpret. Without them, GDB has a harder time showing you useful information. Next, you should enable core dumps on your system. You can do this by running the command ulimit and limited in your terminal. This command removes any limit on the size of core dump files. If you don't do this, your system might not generate a core dump when the program crashes. When your program crashes, look for the core dump file. It is usually named core and is saved in the directory where the program was running. Sometimes, the system might be configured to give it a different name or location, so check your system settings if you don't see it. To analyze the crash, load the core dump into GDB along with the executable file. You do this by typing GDB your program your core file. Once loaded, GDB will show you the program's state at the time of the crash. You can then use commands like beat, which stands for backtrace, to see the sequence of function calls leading up to the crash. You can also examine specific stack frames with the frame command, or check the CPU registers with info registers. Viewing the source code around the crash point with list helps you understand what the program was doing. Printing variables with print shows their values at the moment of failure. By analyzing the instruction pointer, call stack, and variable states, you can identify issues like null pointer dereferences, buffer overflows, or use after-free errors. Core dumps are especially helpful for bugs that are hard to reproduce or happen intermittently. They let you investigate after the fact without needing to recreate the crash. Advanced users can work with ELF format core dumps, debug multi-threaded programs by examining each thread state, and adjust GDB settings to include or exclude certain memory regions. Mastering these techniques turns crash reports into clear clues, helping you fix bugs faster. Getting comfortable with core dump analysis makes your debugging process more efficient. It turns a confusing crash into a story you can read and understand. With GDB, you can see exactly what your program was doing when it failed, making it easier to find and fix the root cause.